Hello everyone. In this session we are going to discuss what is radical axis and significance of radical axis in different possible cases of circles. So first of all let us understand what is the meaning of radical axis. Okay. Radical axis is the locus of point is the locus of point from which from which tangents drawn to circle drawn to circles are equal in length are equal in length. Now, what is the meaning of equal in length? Or what is the meaning of length of tangent? So, length of tangent is root S1. Now, what is the meaning of root S1 over here? Suppose, let us say, equation of circle is S is equal to, or S implies x square plus y square plus 2gx plus 2fy plus c is equal to 0. Fine. Now, let us say we have a point P x1 y1, and from this particular point we can draw two tangents, right? This point is lying outside the circle, so we can draw two possible tangents from this point P to circle S. So let us say we draw two tangents to circle S. This is our circle S, and let us say we draw two tangents from this point P to this circle. So we have to determine the length of PT. Let us say this is PT and this is PR. So we have to determine the length of PT. Expression for that is root S1, and meaning of root S1 is, what is the meaning of S1? First of all, let us understand what is the meaning of S1. Meaning of S1 is just that you have to replace x1 y1, that is x coordinate and y coordinate of point P in equation S. S1 is equal to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal c not equal to 0. It is not equal to 0. It will not be equal to 0. Why it will not be equal to 0? Because x1 y1 point is lying outside circle and not on the circle. Fine. So this is s1, and root s1 will be equal to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c whole root. Fine. So this is our root S1. Now there is a point, and point is same. Point is x1 y1 only, but we have two different circles. First circle is S is equal to 0. Let us say another circle is S dash is equal to 0. This is S is equal to 0. Let us say another circle is S dash is equal to 0. S dash is equal to 0. And S dash has equation x square plus y square plus 2g dash x plus 2f dash y plus c dash is equal to 0. So this is the equation of S dash is equal to 0. Okay. Now that particular point P, if we draw a tangent from that point P to this circle S dash, root S dash 1 will be the length of tangent that is drawn from point P to circle S dash. So for a radical axis is a locus of point from which tangents drawn to two circles are equal in length. That is, root S will be root S1 will be equal to root S dash 1. Fine. Now just whole square both sides. We will get S1 is equal to S dash 1. This is the equation of radical axis. This is the equation of radical axis. This is the equation of radical axis, and interestingly it will be equation of a line. How can I say this? S1 was equal to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Fine. S dash 1 will be equal to x1 square plus y1 square plus 2g dash x1 plus 2f dash y1 plus c dash. Now if they both are equal, equate them up, this term x1 square y1 square will get eliminated on both sides. On from LHS and RHS it will be eliminated. So finally we will have 2gx1 plus 2fy1 plus c is equal to 2g dash x1 plus 2f dash y1 plus c dash, and from this we have 2x1 g minus g dash, 2y1 f minus f dash plus c minus c dash is equal to 0. So students, this is the equation of radical axis. This is the equation of radical axis. Also, this x and y1 point is variable, right? This is not a fixed point. This is a variable point. We have to find locus of point. So we will write this x and y1 as xy only. So 2x g minus g dash plus 2y f minus f dash plus c minus c dash is equal to 0. It is the equation of radical axis. Equation of radical axis. But we have to now determine, or we have to understand the significance of radical axis in different possible cases of a circle, different possible cases of two circles, right? So what are the different possible possibilities in two circles? Circle first of all, the first case is distance between the centers of two circles is more than their sum of radii, more than the sum of their radii. That is, two circles are not intersecting and lying outside of each other. So first case is, this is the first case, case 1, when distance between the center of two circles is more than the sum of their radii. Case 1, O1, O2, that is the distance between O1 and O2 is more than R1 plus R2, the first case. So in first case we have two circles, fine, and distance between their centers is more than the sum of their radii. So these are two circles. This is O1, this is O2. Although we need not to go depth in depth into this, but what we have to understand is just this, that what is the significance of radical axis over here. It is not much of that significance over here, but what we can understand in this particular case is, or in any particular case is, the line joining the center will have a slope. Can we find it out? Yes, we can find it out. O1, center of O1 is, coordinate of O1 is minus G1 comma minus F1. Coordinate of O2 is minus G2 comma minus F2. Fine. Let us find the slope of O1 O2. Slope of O1 O2. That is interesting. So slope of O1 O2 is minus F2 minus F1, difference of y ordinate upon difference of abscissa, upon minus G2 minus G1, and that is equal to F1 minus F2 upon G1 minus G2. This is the slope of line joining the centers, right? Now let us see what is the slope of radical axis. So slope of radical axis is, I hope it is clear to everyone that slope of any line is minus coefficient of x upon coefficient of y. So it is equal to minus coefficient of x, that is minus 2g minus g dash, upon coefficient of y is 2f minus f dash, and this is minus g minus g dash upon f minus f dash. I hope it is not hiding due to the video. You can write it down right now. So this is minus g minus g dash upon f minus f dash, and this is f1 minus f2 upon f1 minus f2. Okay, this is center is not minus g2 minus f2, it is g1 f1. It is not g1 f1. We will write it as minus g minus f, and this is not g2 and f2, but g dash minus f dash. Okay, minus g dash minus f dash. Whatsoever we write, we can easily understand that this red color expression and that blue colored expression, if you multiply these two expressions, their product will be minus 1. Their product will be minus 1. That is of our interest. Okay. So this is f minus f dash upon g minus g dash. You can clearly see that if you multiply this red color expression and this blue color expression, the product will be minus 1. So it means radical axis is perpendicular to line joining the centers, right? So radical axis is, we should write it down. Radical axis is perpendicular to line joining the centers of two circles. And I will leave a case to you. I will leave a particular part of this to you. If radii of both circle is same or two circles are congruent, then radical axis will not only be perpendicular to line joining the centers, but it will also be the perpendicular bisector of line joining the centers. So this you have to understand by yourself. Fine. If there is a doubt, you can ask me for again about that, but you have to think about it yourself. Okay. So radical axis is a line perpendicular to, it is a locus of point although, but it is a, now we can say it is a line which is perpendicular to line joining the centers of two circle. Okay, fine. And what do we have in this? That tangents drawn from any point of this line to two circle are equal in length. So this yellow colored line segment, let us say this is A and this is B. So this AB should be equal to this AD. Okay, AB and AD should be equal. Fine. So this was case 1. This is not much of interest, but case 2, case 3, case 4, they all are very much interest to us. Okay. So case 2, if two circles are touching each other externally, case 2, O1 O2 is equal to R1 plus R2. Two circles are touching each other externally, not internally. Okay. So let us draw the figure. Circle first circle, and we have second circle. They are touching each other. So distance between their center is equal to sum of radii. I hope it is clear to everyone. So distance between centers, this is O1 O2. Now see, what is the significance of radical axis over here, or what will be the line of radical axis, where it will lie. So radical axis is the locus of point from which tangents drawn to two circles are equal in length. Okay, radical axis is the locus of point from which tangents drawn to two circles are equal in length. So let us take any point. Let us to understand it. We know it is perpendicular to line joining the centers, but we have to understand where should lie. So let us take any point and just understand this thing. Let us take a point A and draw tangents to these two circles. This is AB. This is AB and this is AC. Fine. This AB and AC should be equal. Also, interestingly, if I draw a tangent from A, to let us say this point P, touching which is the common point of both two circles, what I can say is what should be true over here is this AB and AC. This AB and AC, they are equal. From A, I can draw two tangents. Fine. This is AB, and there must be another tangent. Also from A, I can draw two tangents to other circle, AC, and let us say other tangent, that is AE. Dear students, it must be clear to everyone that if we join this point P and A, if we say AP is a tangent. Also, it is a common tangent to both circles, right? So AP, what we can see, length of AP and AB, they will be equal. Length of AP and AC, they will be equal, and AB AC, they are equal. So it means the radical axis The radical axis should be the points, should be the line which contain these points, which contain the points, or radical axis should be the line which contains that the indirect common tangents. Dear student, this line AP, if I extend it, this line is indirect common tangent because two circles are lying on the opposite side of each other, are on the different side of each other. So this line AP, if I extend it and term it as L, this line L, for this line L, the centers of two circles are lying on the different sides. So this line L is the radial axis for this pair of circle, because for this particular line L, any point lying on this, for any point lying on this, if I draw tangents from any point lying on this line L to two circles, they will be equal in length. So thus, equation of radial axis, or radial axis will be the line, will be this indirect common tangent. So for this case, O1 O2 is equal to R1 plus R2. Radial axis is indirect common tangent. Be very clear about it. Indirect common tangent. And interestingly, we can find its equation as well, because the equation of radial axis is S minus S dash is equal to 0. S is equal to S dash, or say S minus S dash is equal to 0. So its equation is S minus S dash is equal to 0. Okay. Case 3, another interesting case. Case 3, that is two circles are intersecting. Two circles are intersecting. O1 O2 will be less than R1 plus R2 but greater than mod of R1 minus R2. I hope it is clear to everyone that O1 O2 is O1 O2 is greater than R1 plus mod of R1 minus R2 but less than R1 plus R2. But less than R1 plus R2. Two circles are intersecting each other, right? Let us draw one more circle. Now, where will radial axis lie? Dear students, we know equation of radial axis is S minus S dash is equal to 0. Now, just think that these 2 points A and B, they are the only 2 points, or there are more than there are other points as well, but what we can observe, for these 2 points satisfy equation of both circles. It means if you replace coordinates of A in S, it will be equal to 0. If you replace coordinate of A in S dash, it will be the same. So it means for these 2 particular points, I can say for these two circles, I can say A will make them 0, both of them, right? There are for other point is B. So A and B are 2 points which will make both the circles 0, right? So I can say S is equal to S dash. S is equal to S dash for A and B. Interestingly, S is equal to S dash is a line, and these are 2 points. So it means S is equal to S dash is a line joining these 2 points A and B. And if we join these 2 points A and B, what we can see is, if we join these 2 points A and B, we have after joining these 2 points A and B, what we can say, this line L has equation S minus S dash is equal to 0. Fine. This has equation S minus S dash is equal to 0, and a part of this AB act as a chord for circle 1, for circle with center O1, and for circle with center O2. It acts as a chord for first circle as well as second circle. So this AB is a common chord. A chord which acts as a chord for 2 circles is a common chord. So this AB is a common chord for these 2 circles. So it means s minus s dash is equal to 0 represents it is a radical axis. Please understand, it is a radical axis. It is a radical axis for if we consider the line, but AB is a line segment, and there it acts as a common chord. Fine. So it represents common chord. Okay, it represents common chord. Fine. This was case third. Now let us move forward for another case, that is two circles touch each other but not externally, internally, internal touching. That is O1 O2 is equal to mod R1 minus R2. So case 4, O1 O2 is equal to mod R1 minus R2. The two circles touch each other but internally and not externally. So O1 O2 is equal to mod R1 minus R2, and that is also a very interesting case. I hope the content is not boring. It is a little out of say context topic, out of and even out of syllabus topic, but it's a very important topic to understand understand the significance of s1 minus s dash is equal to 0, s minus s dash is equal to 0, because it is a part of family of lines, so family of circles. So it is a very important topic with respect to the significance of s minus s dash is equal to 0. Though radical axis is not that important with respect to the syllabus, core curriculum syllabus of JEE Mains or even advanced. So this is first circle. Let us draw one more circle inside the circle, not inside but touching this circle internally. Let us say these two circles touch at point P. Fine. Now again, what is the significance of radical axis? Radical axis is a locus of point from which tangents drawn to two circles are equal in length. So we can see, let us take a point A. It is very clear. If from A tangent to to both circles touches at point P. Let us say from PA we draw a tangent and it joins. We can join AP, and from A we can also draw a tangent to a smaller circle, that is AQ, and from A it is very obvious. It is very obvious from external point we can draw two tangents. But important thing is, if from that external point we draw one tangent which touches both circles at point of contact, then our work is done, because AQ is equal to AP, and from A, if I draw a tangent to bigger circle, let us say AR. So AR is equal to AP, right? AR is equal to AP and AQ is equal to AP. I hope it is clear to everyone that from external point you draw tangents to a circle, they will be equal in length. So AR is equal to AP, AQ is equal to AP. Combine these two, you will get AR is equal to AQ. AR is equal to AQ. So this locus of point A, A is a point from which tangents drawn to both circles are equal in length, and there will not be just one such point. There will be infinite such point, and the locus of those points will be radical axis. And what we can see, you take any point on this line AP, or if we extend this line AP, if you take any point on this extended line AP, right? You take any point, what you can see, you can draw two tangents that are equal in length. You can draw two tangents to these two circles that will be equal in length. And this line L over here is common tangent, but what kind of common tangent? In this particular case, there is only one type of common tangent possible, that is direct common tangent. The two circles or centers of two circles are lying on the same side of line. So this L represents, here L s minus s dash, here L s minus s dash is equal to 0, represents direct common tangent. Now we have just two more cases, but they are very important. At least for the last case is very important, right? So case fifth, what we have in case fifth, now the two circles, one of the circle lie inside the bigger circle, but their centers don't coincide. So it's not the concentric case. It will the concentric will be the last case. So we have two circles, and one of the circle lie inside the circle, but they are not concentric. So will there be a radical axis? Yes, there will be, but it is not much of significance. The case fifth is somewhat like case one only. Case fifth is somewhat like case one only, but here the two circles do not that in that case also the two circles did not intersect. In this case also the two circles will not intersect. But first case the two circles lies completely outside of each other. But in case fifth, one of the circle lie inside the bigger circle. So case fifth will be a figure of case fifth will be of this type. Bigger circle and the smaller circle will lie inside the bigger circle. So a smaller circle lies inside the bigger circle, but they are not concentric. Be very clear about it. Now there is no point of common chord. There is no point of common tangent. So significance, radical axis is not of much significance, right? There will be a radical axis, though there will be a radical axis. Fine. It will lie outside both circles. It will lie outside both of the circles. Fine. So somewhere there will be a radical axis, though it will be perpendicular to line joining the centers of two circles. So let us say center of first circle is O1, this is O2. You join O1 and O2 and extend it. So radical axis will be perpendicular to O1, O2 or line joining the centers of two circles. Case 6 is very interesting case and very important case, because in case 6 there will not be a radical axis. In case 6, that is O1 O2 is equal to 0. Case 5th was O1 O2 less than mod of R1 minus R2, but case 6th is O1 O2 is equal to 0. Two circles are concentric circles. Till the time I am making the figure, just think why there will not be a radical axis. Just think about it. Let us say this is circle S is equal to 0. And there is one more circle S dash is equal to 0 lying inside the, I'm sorry, let us make the figure again. It's fine. I hope you must have got the reason why there will not be a radical axis. There's some issue in the figure. Just, it's fine now. Let us consider this only. So this is S dash is equal to 0, and what we can see, they both have same centers. Same centers. Now S minus S dash is equal to 0 represent, what does it represent? Let us see. Equation of S is equal to 0. Let us write equation of S is equal to 0 as x square plus y square plus 2gx plus 2fy plus c is equal to 0, and S dash is equal to 0 represent x square plus y square plus 2gx plus 2fy plus c dash is equal to 0. Why is it so? They both have same center. Minus g minus f will be the coordinate of center of first circle and for the second circle as well. So now s minus s dash is equal to 0 represents s minus s dash is equal to 0 will be c minus c dash is equal to 0, which is not true, which is false, which is bogus. It is not true. Why is it not true? C and C dash will not be same. If they are same, they will be the same circles, right? They will be coincident circles, but that is not the case. So C minus C dash is equal to 0 is not true. This is false. This is bogus. So they will not be a radical axis. In this case, no radical axis. Fine. So these were six different cases for for the radical axis, and we have understood the significance of s minus s dash is equal to 0. I hope this video was clear to everyone. If there is any doubt regarding this, please do ask. Okay. Okay.